Thanks for the introduction. So, good morning, ladies and gentlemen. I'm Darryl Lee, the Consortium Manager for ROS-Industrial Asia Pacific. Today, I'll be sharing on our consortium updates and effort on ROS2 based development. Before I begin, I would like to thank Prof. Alfred for his opening speech and Mr. Tan Ching Yang for his keynote sharing. Next, please. So for those who are not familiar with us, ROS-Industrial Asia Pacific is managed by Advanced Remanufacturing Technological Center, ARTC. We are leading public-private partnership research and Institute of A-Star for advanced manufacturing in the region. Working closely with the manufacturing industry partners, we develop technologies for industrial adoption, which includes robotics, automation, and digitalization. Next. So ROS Industrial, it's a global collaboration between Southwest Research Institute in Texas, Fraunhofer IPA in Germany, and A-Star ARTC in Singapore, each taking care of the three main regions. Together with our industrial members, we form a global consortium to advance open source robotics and ROS for industrial applications. I'm delighted to share that we have Coursera and Infineon both have joined us as consortium members here in ROS Industrial Asia Pacific since our last Asia Pacific workshop. They joined our global network of 80 over members supporting the advancement of ROS for the industry. As a member of the ROS industrial ecosystem, technology and solution providers, end users, and research institutes come together to co-innovate and advance development of new ROS capabilities for the industry and tap on each other's ROS expertise to scale up robotics faster and contribute back to our open global community. Next. So here in ROS Industrial Asia Pacific, I'm proud to share that our vision is to be an international acclaimed default partner in Asia Pacific for open source robotics, while our mission is to develop and deploy ROS2 native technology to support international ROS community and Singapore robotics ecosystem partners in their adoption of open source robotics. Next. Today, there are three main ROS2 development activities which I will be sharing, namely perception, manipulation, and software quality. These are our ongoing effort to accelerate the adoption of ROS by focusing on formally tested packages that are easy to set up and deploy, and is also flexible enough to be customized for different use cases. I'd like to take this chance to also thank National Robotics Program, NRP, on their support towards open source robotics advancement in Singapore. Next, please. So first up, easy perception deployment, referenced as EPD. This package provides robotic vision capabilities, which is easy to configure and deploy using the state-of-the-art machine learning algorithms. This package has capabilities to perform object segmentation, localization, measurements, and tracking, and comes with a user interface to help user to train and deploy even if they are not an expert in machine learning frameworks. We also leverage on an open standard ONNX format for deployment of machine learning model, which can work with different machine learning libraries. Next, please. So there are multiple use cases which we can leverage on EPD packages. And these demonstrations showcase how a Delta robot can perform quick and pick and place on a reflective and almost featureless sachet from a moving conveyor. EPD can also be configured based on the use cases by considering these parameters such as classification, counting, color matching, localization, and tracking. Next. We have the full release candidate of this package in our ROS-Industrial GitHub and can be leveraged for commercial and application with its Apache license. Currently, we are working with on a few direct projects with some of our consortium members who are adopting it to address some of the industry use case. So do visit our industrial GitHub to download it if you can use it. Next, please. The second package that I will be sharing today is Easy Manipulation Deployment, referenced as EMD. This package provides three main capabilities. First, the work cell builder. It is used to create a work cell representation through a quick and intuitive GUI. Second, the grass planner, which is modular and flexible, that can be used to generate different architecture for different end effector hardwares. We use an algorithmic approach for grass planning over a machine learning approach, as this helps us to provide a more generic solution. Finally, the robot path planning and execution, it's being executed via MoveIt, which is a well-established ROS package in this region, in this area. Next. EPD and EMD package can be integrated to train and deploy custom computer vision model to provide a modular and configured manipulation pipeline for pick and place tasks. So we are also looking at future iterations of grass planning, which will involve integrating features that is available in certain end effectors, such as force feedback detection and close finger distances for finger grippers. Next. Another interesting capabilities is the multi-robot dynamic collision avoidance support. It uses a multi-threaded collision checker in real time to check for potential collision. Depending on the physical robot in the safety zones, it will make the decision to either stop the robot totally if it's in the blind zone, else it will replan the next move and publish the next trajectory point for execution. There are multiple use cases which we can leverage on EMD package, potentially in the application of high mix, low volume, machine tending automation, labeling automation, etc. Next. Next. Similar to EPD, we have the full release candidate of this package in our ROS-Industrial GitHub and can be leveraged for commercial application. We are also currently handling some of the direct projects with our consortium members for their use cases. Okay, next. Let me go into the third topic, that is the software quality. As many of you might know that in December 2019, RED 2004 was derived for the standardization of quality process and metrics for ROS package. Since then, we have contributed efforts in developing a set of tutorial and standardized acceptance criteria for testing of software components. We envisage a platform that can be automatically determine the quality level of the software and provide a quality tier badge that can represent the code completeness and integrity. This helps to provide a coherent and automated assessment method that ties to RED 2004 and provide maintainers with a consistency in quality, software quality, and provide end users with confidence to use the packages. Next. So how does this quality badge works? Firstly, the developer will upload their code into their repository, such as GitHub or GitLab. After that, the software testing can take place, and industrial CI pipeline can automatically determine the different quality level on the output results and metrics. In turn, this would provide the developer with an understanding on how established the codes are and allow the developer to further improve on their codes if they intend to. Over time, these batches can help the code standard in the open source community to improve its standard and provide industrial organizations with greater transparency and more informed decision when adopting ROS package for production and deployment. Thanks. Next. Next up, I would like to quickly touch on our effort on ROS interoperability with Robotics Middleware Framework, RMF. So ROS Industrial Asia Pacific is currently collaborating with industrial partners to test bed RMF via a physical trial for scalable and autonomous operations in the facility management sector. This project addresses the problem statement of robot fleets operating in silos with no common control and inefficient robot task management. The second one, where we are also working on a focused technical project, FTP for RMF, and with some of our consortium members to develop new RMF capabilities required to address common manufacturing problem statement and set up a simulation environment to conduct performance benchmarking of task allocation, traffic scheduling, and interoperability of robots. Some of the significant project outcome would be project participants have agreed to open source the significant portion of it. Next. Next, let me share some of the updates on our outreaching efforts. So ROS Industrial Asia Pacific had held a 5 days boot camp in March for some of our Singapore Polytechnic students to get them started in ROS. I could say that it was a fun and fulfilling event which students have enjoyed it greatly. Within the same period, we actually held a 3-day training workshop on ROS2 basics, EPD, and EMD. And it was curated and delivered to our consortium members. This training workshop has provided participants with good technical explanation of the working principle and exposures to the packages. Moving forward, ROS Industrial is hosting a developer training from 13 to 16 September and a developer meeting on 14 September. Please use the QR code to register your interest, respectively. Alternatively, you can also drop us an email as well. Next. So for future trainings, ROS Industrial Asia Pacific will make the following training topics available on public runs. These packages includes ROS2 basics, EPD, EMD, and navigation 2. We are also looking to provide training via digital platform on AWS Robot Maker and easy-to computing environment to complement our physical training. Hence, interested party do look out for it. Okay, next. Finally, I like to share my key focus for year 2022. So ROS Industrial Asia Pacific will continue to drive industrial adoption and implementation of ROS2 modules. We will continue the work on FTPs, and mobile manipulation will be the next topic. So Asia Pacific Consortium members do take note, we will be in touch soon. Lastly, we will continue the effort on ROS outreach and support robotics initiative and advancement for Asia Pacific. Thank you.